So let's talk about number 3. We got a parametric equation. I think it was e to the t, x equals e to the t. Is it cosine or sine? Cosine t. And y is e to the t sine t. Okay. All right. And so we want to find a few things. We're asked to find critical points. And we're asked to find a tangent line at pi over 4. And then we're also asked to find the arc length. Okay. So the first thing is to deal with critical points. In general, critical points mean something like the max or min points, right? So when where the derivative is equal to 0. And that's fine. I might add, just for the sake of it, points also where you have vertical tangents. That might give us just extra information about. So we want to look for vertical and horizontal tangents. So our tangent slopes come from the derivative, right? But in this case, our parameterized derivative needs to be, dy needs to be with respect to t, and dx needs to be with respect to t. Okay. Now, when we're dealing with slope, of course, a slope of 0 equals a horizontal line. And so when we're dealing with a horizontal line, we want our slope to be 0. That means we want this fraction to be 0, which is to say when a fraction is 0, we want this bit here to be 0, and we want this bit not to be 0, right? So we want y prime to equal 0, but we want x prime to not equal 0. The vertical is the other way, because for a vertical, we want our slope to be undefined. Right? So when our slope is undefined, that means that we have a 0 in the denominator and not a 0 in the numerator. So that's going to say we want y prime to not equal 0, and we want x prime to equal 0 in that case. In a situation where both of them equal 0, you're probably dealing with a cusp or something along those lines. So that's not a vertical or horizontal tangent at that point. So now we have this idea intact. So we just need to find out what x prime and y prime are. So this is pretty straightforward product rule. So we have e to the t, and then the derivative, which is negative sign. Is that right? So negative sine t plus cosine t times the derivative of e to the t, which is just e to the t. And then for y prime, we have a similar situation. We take e to the t, and then the derivative of sine, which is cosine, plus the derivative of e to the t, which is e to the t, and then we have that. Any questions over that? I think that's pretty. Okay. So I can do a few things here. Notice I'm going to want to set each of these equal to 0, right? To get my different pieces. I'm going to simplify this by bringing out the e to the t, and then I'm just going to switch the terms just to make it a little easier. And then this, just keep in the usual way. Okay, so we're setting each of these equal to 0. We know e to the t is never going to be equal to 0, right? So for our x version, we need when cosine t is equal to sine t. I just added sine t on both sides. So that's going to happen when, if we look at our unit circle kind of thing, 45 degrees that way when they're both positive, and this way when they're both negative. So we have pi over 4 and whatever that extra bit on that side. Yeah.
0 is less than or equal to t is less than or equal to pi. So
What's that?
it's between 0 and pi. T is.
Okay, between 0 and pi. So we don't even have that part. Okay. All right. So we're restricted, so we just have this then. Okay. And then for y, this is for x. For y, we have when cosine is equal to negative sine, and since we're restricted, that's going to be this point over here, which is looks like 3 pi over 4. Okay. Yes.
Can you explain why cosine t equals sine t?
Yeah. So in this case, I'm using this situation. This factor is never equal to 0, so I'm ignoring it, and then I'm looking at cosine t minus sine t equals 0, and then I added a sine t to both sides, so then I had cosine t equals sine t, and that's, so I moved from here to here, and then I just kind of shortcutted it by recognizing that this happens at the pi over 4, at the situations where this length and this length are the same, which is here. And for here, it's the same thing except one's negative and one's positive. So that's why it works in this case.
Okay, thanks.
All right, so we have that situation. So when x is equal to 0, that means a vertical. So we have a vertical here. And here, that would be a horizontal. So we've dealt with the kind of the critical points. Now to make a tangent line, we're using a similar idea. Remember, our tangent line looks like this. We have y minus y1, or y at our t value. Our t value in this case was pi over 4. So y of pi over 4, that's a point. Then we have the slope, which we know is dy over dx. But in our case, those are both in terms of dt. So that's our slope, and then we have x minus x evaluated at pi over 4. Yes?
Why don't we have to use that crazy curvature equation right now? Like, do we have to use that at any point, or?
It didn't ask us to find the curvature.
So when you have parametrics, it's
So if it asked us to find the curvature, then yes. If it asked us to find various other things, maybe we would use it. But like for the radius of an oscillating circle or something like that. But in this case, I think we can just put it in this term. So y of pi over 4, we'll look at our original. That's whatever sine of pi over 4 is. So looks like that. E to the pi over 4. And sine pi over 4. And then our part here, we're looking at this over this. We have e to the t cosine t plus sine t over e to the t cosine t minus sine t. That's our slope. And then x evaluated at e to the pi over 4 cosine pi over 4. and then any simplification we need to do from there. Clearly these will cancel, and actually, so those are gone, and we're evaluating it at pi over 4. So we can do that. Okay. And we can talk about what sine of pi over 4 if we're using our units. That'd be 1 over square root of 2. 1 over square root of 2. That's 1. So square root of 2 over 2 if we're rationalizing. So y minus e to the pi over 4 times square root of 2 equals square root of 2 over 2 plus square root of 2 over 2, and then of course this is square root of 2 over 2 minus square root of 2. Okay, so then we get a situation where the denominator is 0, and so this whole thing is undefined, which means we have a vertical line, which, I mean, actually we already knew that, right? So x then is x equals the point where it is at x, which is pi over 4 times square root of 2 over 2, I believe. So we're making a vertical line at the point of the x value of this equation. So if you think of it, we have some shape going on here. At time pi over 4, the x position is e pi over 4 times square root of 2 over 2. So at that point, there's a vertical line that is tangent to that parametric curve. So that's why I have that. And then in terms of arc length, go back to here. Remember that the arc length, if we're talking about a small piece of it, right? We're trying to find the small change in y divided by, small change in y, the small change in x, and then this piece uses the Pythagorean theorem. So whatever this value is, ds is equal to the square root of x prime squared plus y prime squared, right? So that's one small piece, but we're adding up a bunch of those small pieces. So we're using the integral of at time a, time b, integral of x prime squared plus y prime squared dt. And in our case, you said it goes from 0 to pi, right? So we're looking at, we're looking at 0 to pi, and so we need this squared here plus this squared, taking the square root. So let's try to do that real quick. We have 0 to pi square root of this squared e to 2t squared plus e to 2t plus. Okay, so when we do this out, we'll get cosine squared, we'll get sine squared, and then in between we'll have minus 2 cosine sine. And then the cosine squared plus the sine squared part will be 1. And so then we have e to the 2t. We have 1 minus 2 cosine t sine t, like that. And I'm just going to bring that term out because we have it same in each one. So plus, then we're going to do a similar thing. When we square that, we'll have cosine squared, we'll have sine squared, and then in the middle term will be 2 cosine sine. So then we have 1 plus 2 sine t cosine t. Okay. And that's all under the square root and everything. So then we have 1 plus 1, we have this negative, this positive, so those cancel. So we have 2, so it means we have 2 times e to the t square root like that. Okay. So what do we do from here?
You can pull them into T. You can pull up the E to the T. Because it's squared.
Okay. So the nice thing here is that this is squared, so we have basically the square root of 2, which is constant. And we have the square root of e, so that just gives us e to the t, and then we're here, right? So then we have square root of 2 times e to the t, evaluated at from 0 to pi. Which then square root of 2 e to the pi minus 1. Okay. And that should be our arc length.